Okay, welcome to video number 12 of the How to Wire Schneider PLCs. We are working in the Modicon M221 family, and today we're looking at wiring the onboard or built-in 0 to 10 volt analog inputs on a M221. Let's move over to take a quick look at how we access them. First of all, if you take a look at all of your, or any one of your Modicons, you're going to see this little window over here. You can pry that little window open. There is a set of jumpers that comes along with your PLC. When you buy the PLC, they're pre-made jumpers. They're actually 3 feet long. You click them in, and then what you can do is you bend your cables back up through the top, and then you can place that little cover plate back over top. And at that point, you have got your analog inputs connected into the PLC. It is a proprietary type of connector and cable, and so if you don't have it, you're going to have to order another one through Schneider. But let's take a look at what the actual inputs themselves are set up for. We've got two inputs that are going to be built into every M221, whether it's going to be the monolithic or the cartridge style. They're going to go and be single-ended, and they've got a 0 to positive 10 volts DC input. The resolution digitally is going to be 10 bits, which tells us about the amount of fine data that we can take in, basically how coarse our measurements are going to go and be. The smallest value that we can measure is going to be 10 millivolts or 1/100th of a volt. And the input impedance itself runs at 100k ohms. So you want to match that with what you have for your 0 to 10 volt source that's out in the field, whatever that field device is. You want to make sure that it matches with 100k ohms. 12 milliseconds delay time between scans that we are going to go and have, and it's a 1 millisecond per channel plus 1 scan time for how long it actually looks at that signal that's coming into it. So it's a decent looking input that we are going to go and have off of them. They do get relatively unnoticed. You know, a lot of times people don't see them behind that little plate that's going to be there, so they do skip out on knowing that they're there. They are also not going to be labeled on your PLC other than a negative and a positive over here. They don't tell you which one is going to be analog 0 and analog 1. Relatively simple once you've actually got your PLC running, you know, to go and determine which is which, but the one on the right hand side is going to be my 0. The one on the left hand side is going to go and be my 1. And then they give us the 0 volt or the negative signal is going to be black, and the positive is going to go and be red. Here they're showing us that the negative or the black goes into there and the positive goes in like that. Really straightforward connections. Let's take a look at how one looks physically. Over here we have got our standard setup that we've looked at through a lot of these other videos. We see that we've got a transistor style of PLC over here, and we see that we have lifted off that cover over there and inserted in the connector, and the connector comes with its own wiring whips that are going to come out. We're going to take those down and insert them into a set of DIN rail terminals over here. Obviously in the field you're going to go and run these things very neatly out and around. We just wanted to show what they look like inside of there. And what that means is that we can now go and take in 0 to 10 volts. So over here we have a 0 to 10 volt field device. We've got the cabling that's coming in. We've got shielded cabling coming in from that field device, and what we see is that we have got a couple of conductors inside of there, positive, negative, and then we've also got this green, which is going to be the internal cable ground, and then we've got this one over here, which is connected to my cable shield. We're going to start by dealing with my shield and my ground, so I'm going to go and take my ground over to my grounding terminal. I'm going to go and take my shield over to my grounding terminal as well. We do that on the source end that we are going to do that, and then we would isolate the shield over at the field end. So I've got that carried into here. The next thing I'm going to do is I'm going to go and take my negative. Now we're going to work with this side over here, which is analog 0. This is analog 1. So the first one inside of here actually is this terminal over here. We're going to go and take our negative into there, and we are going to go and take our positive into there. And that's it. We've got a 0 to 10 volt input that is being brought into my PLC right now, which means that somewhere out in the field I'm going to get a signal. That signal is going to get translated into 0 to 10 volt. I take it into my PLC where I can then go and translate it into, you know, whatever it is that we're scaling in. We're also going to go and take a quick look while we're on this, what happens if you have got a current device. Now, if you've got a current device, you do have the option that you could take a 4 to 20 milliamp cartridge and place that one inside of there. But if you've only got a single current device and it has to be current coming from that field device, we do have another option. That option is going to be to use one of these over here. If we zoom in a little bit, It is a DIN rail mountable device, the RMCN22BD. It's got 24 volts DC for power in. And then over here, it's got an I, VI, and IPG. These are going to be inputs where I could place in a volts, current, and then my earth or my negative, my protective ground that they have. And then I can convert to either IO, current output, VO, current voltage output, and then this is going to be my common for that one. This is a really, really handy small device that is available. We're just going to skip over to it right now. It's a Harmony analog isolated analog converter. And basically it allows us to take 0 to 10 volts in and convert it to 4 to 20 milliamps, or in the case that we are looking at, we can go and take 4 to 20 milliamps in and convert it to a 0 to 10 volt, which is what we want to have, because that 0 to 10 volts is what my PLC itself can actually run on. Let's go back to our drawing and finish that one up over here. So if I'm going to be using a converter, I've got my 4 to 20 milliamp that I'm going to have. First thing I'm going to do is I'm going to deal with my cable, and I'm going to go and take the shield, and I'm going to go and take the bond in, tie those down. Then the next thing I'm going to do is I'm going to go and say that I'm going to take my inputs in. So whatever I'm feeding in from the field, which is going to be this black and red over here, the black or the negative goes to the PG terminal over here. The red, which is a current input, would go to the I terminal, or the small I terminal like that. What this is going to do now is it's going to take that 4 to 20 milliamp signal, it's going to convert it to a 0 to 10 volt signal that I could then run to my PLC. And we'll just switch colors over here. We'll go to European colors, where we're going to have a blue for the negative. We'll go for this PG over here, which is going to be my negative. And we can run that in like that. And we will take a brown, and we're looking for a voltage output from this converter over here that we will then go and take into my positive like that. And so now, although it's a pretty tight, tangly little set of wires that we have inside of here, what we're doing is we are taking in a signal, a 4 to 20 amp signal that we are going to go have here. We're converting it then to voltage so that we can take it into the onboard without having to add any extra onboard cartridges. All right, that is it for how to wire the analog inputs that you are going to go and have. There are no built-in analog outputs. There's only analog inputs. If you want to go outputs, we're going to have to go and use this cartridge expansion, which we'll take a look at in subsequent videos.